There's a quarry in Aswan, Egypt, where the stone still bears the shape of an intention, carved directly into the bedrock, not removed from it, not finished, and not moved. It is the largest known obelisk ever attempted in the ancient world. It is 137 feet long. It weighs an estimated 1,200 tons, and it has never left the ground. If it had been completed, it would have dwarfed every standing obelisk in Egypt. The Lateran obelisk in Rome, the tallest surviving obelisk in the world at 105 feet, would have stood beneath it like a younger sibling. Instead, the unfinished obelisk lies exactly where it was abandoned, still fused along one side to the granite that birthed it, a monument to a process that stopped mid-sentence. The official explanation for why it was abandoned is a crack in the stone. A flaw appeared. The project was halted. Workers moved on. Reasonable, plausible, and in my opinion, almost certainly incomplete. Because here's what keeps drawing me back. It's not the crack that's interesting. It's everything before the crack. The marks on the sides of the stone, the geometry of the cut, the question of what tool exactly was used to shape 1,200 tons of hard granite, and whether that question has ever been satisfactorily answered. I don't think it has. Before we get into the marks, it helps to understand what granite is, because the material matters here. Granite is one of the hardest naturally occurring stones on Earth. On the Mohs hardness scale, the standard measure of scratch resistance, granite typically scores between 6 and 7. Quartz, which is a major component of granite, scores 7. For comparison, copper, the metal Egyptians are widely documented to have used for tools, scores between 2.5 and 3. Let me make that comparison concrete. Copper is roughly half as hard as the material it was supposedly being used to cut. You cannot scratch granite with copper. You cannot chisel it. If you press a copper tool against granite and strike it, the copper deforms. The granite does not. This is not controversial. This is basic materials science, and it creates an immediate problem for the official explanation of how the unfinished obelisk was carved. The answer offered by Egyptologists, the accepted consensus answer, is that workers used dolerite, a type of igneous rock that can score up to 7 on the Mohs scale. It is harder than copper, and hard enough to abrade granite through repeated percussion. The technique is called pounding, and it involves workers hammering dolerite balls against the granite surface, gradually wearing it away. This is not a fringe theory. It is the mainstream position, and it is supported by physical evidence. Dolerite balls have been found at the quarry site. Experiments have been conducted. The technique demonstrably works to some degree, but working to some degree and explaining what we actually see in the stone are different things. When you look closely at what is in that rock, the pounding story begins to develop some uncomfortable gaps. The sides of the unfinished obelisk are not rough. They are not randomly pitted in the way that sustained percussion would create. They show regular, evenly spaced striations, marks that run in consistent parallel lines across the stone surface. This matters, because it is not what pounding produces. When you pound a surface with rounded stones, you create a texture that looks like what it is, repeated, overlapping impact points. The resulting surface is rough, irregular, and concave in a characteristic way. This texture is well documented. It appears on other Egyptian stonework. Experimental archaeologists have reproduced it. The marks on the unfinished obelisk are not those marks. The striations are approximately equal in depth. They are spaced at regular intervals. In multiple locations, they show a directionality, a consistent orientation suggesting the cutting implement moved along the surface rather than striking it. Several researchers, including Egyptologist Dennis Stocks and engineer Christopher Dunn, have noted a discrepancy between these marks and the expected output of dolerite pounding. Stocks spent years conducting hands-on experimental archaeology with ancient Egyptian tools. His work is careful, peer-reviewed, and genuinely illuminating. He showed that ancient Egyptians could accomplish remarkable things with the tools they had. He also encountered what he described as the limits of reproduction, areas where the experimental results did not fully match the archaeological evidence. Dunn goes further, arguing that the marks are consistent with a cutting implement moving along a fixed path at a controlled depth, more suggestive of a mechanically guided tool than a handheld tool. His conclusions are contested. His observations about the marks themselves are less easily dismissed. I keep returning to a simple question. If pounding stones explain the texture, why has no controlled experiment successfully reproduced that texture at that scale? The answer I keep hearing is that we haven't tried hard enough. We haven't allocated the resources. We haven't assembled the right team. Maybe. But it is also worth asking whether that explanation is as satisfying as it sounds, or whether it is the kind of explanation that functions primarily to close down inquiry. Let's do something the ancient history documentaries rarely do: the actual arithmetic. The unfinished obelisk represents approximately 11,000 cubic feet of granite that needed to be removed from the surrounding bedrock. We'll ignore the question of final shaping and polishing and focus solely on the excavation, separating this object from the rock around it. If we accept the pounding stone hypothesis, we need to estimate the rate at which dolerite percussion removes granite. Experimental archaeology has provided some figures here. In documented experiments, skilled workers using dolerite balls can remove roughly 5 to 6 cubic centimeters of granite per hour per worker. That's a generous estimate from favorable conditions. At that rate, removing 11,000 cubic feet, which is approximately 311 million cubic centimeters, would require in the range of 50 to 60 million worker hours. Spread across a workforce of 1,000 people working 10-hour days, that's roughly 14 to 17 years of continuous labor, 7 days a week, just for the excavation phase. This assumes no rest days, no tool maintenance time, no management overhead, no illness, no accidents, and no workers doing anything other than pounding granite continuously for nearly 2 decades. The Egyptians were extraordinary organizers. Their logistics were real and impressive. But that figure, under those conditions, represents the absolute ceiling of what is physically possible using the documented method. And the issue isn't just time, it's the spatial constraint. The obelisk lies in a trench. As the cutting progresses deeper into the rock, the workspace becomes more confined. The number of workers who can physically access the cutting surface decreases. The ventilation worsens. The removal of debris becomes more labor-intensive. The effective rate of excavation drops. No one publishing serious work on this topic has provided a model that resolves all these constraints simultaneously with pounding stones as the primary tool. The standard academic response is that the math does not need to work precisely, that our experimental rates may be underestimates, that the Egyptians may have used techniques we have not identified, that the evidence of completion throughout Egypt proves the method was sufficient. I take the last point seriously. The Egyptians clearly could and did complete obelisks. The evidence is literally standing in Rome, Istanbul, Paris, and New York. Whatever they were doing, it worked. But it worked, and we understand how it worked, are not the same statement. And I think we confuse them more often than we admit. In the 1990s, a team led by engineer and sculptor Dennis Stocks conducted perhaps the most rigorous hands-on experimental archaeology of ancient Egyptian stoneworking ever attempted. He built replicas of documented tools. He sourced materials as close as possible to what the Egyptians had available. He worked the stone himself. His findings were genuinely significant. He demonstrated that copper drills loaded with an abrasive slurry of quartz sand could bore holes in granite. He showed that copper saws with similar abrasive loading could cut granite. He reproduced features of Egyptian stonework that had previously seemed inexplicable. He also found that his reproduction rates, the speed at which these methods removed material, were slow. Very slow. Certain surface features he encountered in the archaeological record were not easily reproduced by any of the documented methods. His conclusion was not that the Egyptians had secret technology. It was that they probably used multiple techniques in combination, possibly including some we have not fully identified, and that the records we have are incomplete. This is an honest, careful, scholarly position. I respect it. What I find interesting is that it implicitly acknowledges a gap. There is something in the stone that the documented tools do not fully explain. Stocks urged filling the gap with more research. That is good science. But there's a different response to that gap, which is to look at it directly and ask, what would explain these marks? What kind of tool would produce this pattern at this scale in this material? When you ask that question without pre-committing to the answer, some uncomfortable possibilities start to emerge. There is a researcher named Christopher Dunn who has spent decades arguing that the marks on the unfinished obelisk and on other Egyptian stonework are consistent with machining. Not primitive machining, not metaphorical machining, actual mechanically guided cutting tools moving along a controlled path. Dunn is a precision machinist by trade. He has worked in aerospace manufacturing. He is not an archaeologist, and his conclusions about the broader implications of his work, which extend well beyond the obelisk into theories about Egyptian civilization that are deeply speculative, deserve genuine skepticism. But his observations about the physical marks in the stone are specific and technical, and they have not been effectively refuted by the academic mainstream. They have mostly been ignored. This is where I want to be careful, because the narrative of the establishment ignores evidence it doesn't like can become its own kind of faith, a way of believing anything by reframing the absence of engagement as proof of conspiracy. I don't want to do that. What I will say is this: there is a legitimate scientific question about what tool produced those marks. That question has not been conclusively answered. Experimental attempts to reproduce the marks have not fully succeeded. And to my knowledge, no major research institution has funded a systematic effort to answer the question definitively. That last fact is interesting. Not sinister, interesting. Major institutions fund what the field considers important. If the field consensus is that pounding stones explain everything, there is no grant to be written for investigating alternative tool hypotheses. The absence of investigation is not suppression. It is the ordinary functioning of scientific priority setting. But it does mean the question remains open. Open questions deserve acknowledgement, not assumption. We should come back to the crack. The official account says the obelisk was abandoned because a crack appeared in the granite, rendering the project unviable. This is supported by physical evidence. There are cracks in the stone. The abandonment is real. What the crack doesn't explain is the choice to attempt this project in the first place. 1,200 tons, 137 feet. A single piece of stone. Even if we accept every element of the mainstream account, dolerite pounding, copper finishing, large organized workforces, decades of labor, we are still confronted with the fact that someone in ancient Egypt decided to attempt this. Someone had a reason to believe it was possible. Someone had a method they trusted enough to commit enormous resources to the project. That method, whatever it was capable of getting the work to the point of near completion before a geological flaw ended it. The stone shows extensive work. The trench around it is deep. The amount of material already removed is staggering. Whatever was being used to cut this stone, it was working. Something was working. The cracks stopped the project, but not the technique. And the technique, the actual physical process by which a pre-industrial civilization was removing granite at this scale, is still not fully understood. I want to be honest about where I've landed, because I think honesty is more useful than either credulous acceptance or reflexive dismissal. I think the ancient Egyptians were more technologically sophisticated than our standard narrative accommodates. I think there are tool marks in the granite that current experimental archaeology has not successfully reproduced. I think the mathematics of pounding stone don't fully account for the scale of what was accomplished, and I think the field has been too quick to assume that incompleteness in our models reflects incompleteness in our evidence rather than incompleteness in our understanding. I don't think the Egyptians had alien assistance. I don't think there is a suppressed secret technology that modern institutions are hiding. I think the far more interesting possibility, and the more unsettling one, is that a human civilization we thought we understood was doing something we don't yet understand, and that the marks in the stone are its only surviving instruction manual. The obelisk is still there. The marks are still there. The question is still there. And the next person who goes to Aswan and looks at those striations with fresh eyes and the right tools might find something that changes the answer, or they might confirm what we already think we know. Either way, I think it's worth looking. The unfinished obelisk is located in the northern quarries of Aswan, Egypt, and is open to visitors. The site is maintained and accessible. The marks are visible to anyone who looks closely enough.